Hi guys, welcome to Lecture 2 video. Today we'll be talking about databases. Sorry about my webcam not showing. I think Keynote is just a bit strange, so I can't show my video, but you guys can look forward to my face whenever I do demos. So without further ado, let's get started. As a recap, we talked about the client-server model in our first lecture. So this is where clients sending requests and servers responding with responses. And a client can be anything from your iOS device or your Android or your PC. And requests take in the form of a specific URL, and any specific endpoint is a client asking the backend to do a specific thing. And there are lots of different types of ways that you can send in a request. So this can be get, post, put, patch. You may not have heard of put and patch, but those are just variants of post where you're updating a data. Put is usually when you want to update like a small thing. For example, I'm going to Facebook and I want to update my name or update my age. It's just one little thing. And patch is also some similar variant of that, but you don't have to worry about those. Only thing you really need to know are post, get, and delete. Update, I think, might also be another thing, but that's a tangent. And the form that we're using is JSON. So you can also do XML and protobuf, but in this course, we're focusing on using JSON as a data format that we're communicating between client and backend. And as you may have already known from demo 1 and lecture 1, that we have response codes like 200, 201 for creation and 400. And you may have noticed while debugging in Postman that whenever you have an error where your endpoint seemingly doesn't exist, you get a 404. So that's when the Postman can't access your server. All right, so very nice graphics. Request made, route triggered, something happening to the data, and then you return the response. All right, so you may have noticed when you were doing demo 1 and PA1 that managing this Python dictionary as a database, quote unquote, was really annoying. And that's because we had to manually manage this database. And we had to manually increment the counter, we had to add to it, and we had to delete from it. So this adding and deleting is actually quite similar to what you would do to an actual database, but it's not as elementary as we did with this Python dictionary. And there's a lot of optimizations that a database does that we can't do with a Python dictionary. Also, I think it can be quite annoying to have in your file the database that you're trying to interact with. It should actually be quite modular, right? You should separate these things, and that's what we'll be focusing on in this lecture video. So, as I already said, some deficiencies, and here are some that I did not mention yet. So whenever you stop the server, all of your data is lost. So when you restart your server, you may have noticed when you try to use Postman or you're trying to hit an endpoint that you have to start adding in your data all over again. It's because you're literally essentially hard coding your data into this Python dictionary. This does not scale very well, and there's no some sort of formatting enforcement. And by that, I mean you're not really enforcing that the user is sending in a string for someone's name. You're not ensuring that, done is a Boolean or an integer or a string. It should be a Boolean, right? So whether or not I finished my task or finished my writing my post or whatever, but this isn't enforcing some data format, and that can be quite troubling when you want to return data and a client is expecting some format. All right, so databases. The fundamentals. A database is a collection of organized information. You can access it, update it, delete from it. You can have different tables within your database and connect on relationships, but we'll go over more in that in detail later. And yes, as I mentioned, it's implemented as a collection of tables. So this is an example of a table. You have columns, which are the data types. So you have the ID, the name, the quantity, and the price of this database of fruits. So the ID, as you can tell, is unique, and for each ID, you have a row, and that's the particular fruit. So you can think of this as like a Java class or a Python class, and the attributes are the columns, and each row is a particular instance of that object. So the unique identifiers, the IDs, are required for every single item in the table because that's how the database will know how to access that object. Otherwise, it can't really tell. For example, if you had two apples and you didn't name one as Fuji apple and the other one as Gala apple, how would the database know that these were two different apples, right? So that's what you use ID to differentiate between. And also, you could literally just have two apples that were different prices because one farmer was cheaper than the other, but they're essentially still different apples, and you still want to keep track of that. So the unique identifier can get rid of this problem. And in a database that we'll be using, and I will be talking about later, the IDs will automatically increment, so you don't need to manually increment the ID, and then at the ID you update this particular instance of the object. And if you remove an ID, similar to how when we managed our Python dictionary, the ID wouldn't be used again. It essentially was just wiped off the face of the earth, and the next ID that's added in is the last one plus one. So an important clarification that I want to make is that a database is not a table, but a database is multiple tables. And I can show you in this example. So let's just say you are at a company event and you want to save some data. For example, there's like some farmer's market stand with a bunch of fruit and you want to know which employee bought what, but you won't necessarily have one table containing both the employee information and the fruit information. Also, sorry, this example is really strange. I don't know how else to relate employees and fruits, but we'll just go with that, like a company event, and you want to keep track of who bought what. But you don't want to put this big table full of like, okay, John bought an apple and an orange, and then Jane also bought a banana, and Joe bought a blackberry and a pear. You want to keep these two things separate. And if you ever do want to relate them, we'll actually show you guys later what that actually means and how that works as a relationship in a database. But for now, you can just separate these two and know that all of this together is one database. A database does not necessarily have to have one type of data. Like, you don't need to only have employees or only need to have fruits. That's a really big misconception that people have, so make sure you understand that. So here, the IDs are both unique to each table, and you can see that Apple has ID 1 and John also has ID 1, so it's not that John will have ID 4 after banana. So it's for each table, the IDs are starting from 1 and they increment by 1. Okay, so let's go back to why having this table format is so important. So on the right hand side, you see our Python dictionary implementation versus our table implementation in a database. So our dictionary is quite messy, lots of information overload. You can see all these nested braces and brackets are a bit confusing. It's a dictionary with keys, with arrays as values, with nested dictionaries as keys. And you can probably imagine how massive this can get and how unmanageable this can get. So let's talk about the benefits. The data is structured if we have a database. It scales well. We can have tons and tons of data. We can store all of the Cornell students in a database. And getting the data is actually really helpful because it's super fast and you can also get more information that you need. For example, you can say, let me get all the Cornell students who are freshmen, and you can get it just like that because the database has its own optimizations, and I can go more into that in detail in the later slides. But so again, this is the code for how you would manage your Python dictionary as a database. You load your data from a JSON file. For those of you who don't know, if you remember when we did get and post requests and all that, our format of data was JSON. This is the same thing, except it's just JSON data in a text file and the extension is JSON. And we are iterating through our really sad database and we're appending and it's really slow and something could go very wrong and we would never know about it. Instead, we have a very clean SQL code here, and I'll tell you what SQL is later, but baby steps first. So select name from fruit where quantity is greater than 0. This is saying, get me all the fruit where we have in stock. And you can see that the purple things seem to be these special keywords, and the black letters are the actual columns of the database, and the orange thing is like the value. Okay, so I've been saying something called SQL. What is that? It's structured query language, and this is the medium which you will be using to talk with a database. So you might have heard of MySQL, NoSQL, PostgreSQL, SQL, SQLite, SQLite 3. Uh, Very similar things at the end of the day, but they're actually quite different. So in this course, we will only be worrying about SQL, and the interface that we'll be dealing with is SQLite 3. I'm not sure if Alicia will be showing this in the demo, but what you can do is, so make sure you've downloaded SQLite 3, and you can go into your terminal, you can type SQLite 3, and you can start just working with the database. You can start making SQL commands and all that. If that is not shown in the demo video, I can also make a separate video on that, but this is just a nice to have if you're trying to debug and you don't know why something isn't being added to the database, etc. But this is the language that you'll be using, and it's also known as SQL SQL. Please do not call it SQL, it's SQL. And if you're ever interested about MySQL or NoSQL or anything like that, you can come to office hours and I can chat with you about it. But these are some very, very basic backend things, so really super nice to know about. Okay, so overview. This is a language for communicating with the databases. So when we showed you that code before of iterating through the things in a JSON text file, instead we replace it with a one-liner, like select something where fru is like the quantity is greater than 0. That's the language itself. And you can do lots of things. You can create things, get things, update, destroy things. Wow, destroy sounds really scary, but deleting things, yeah. So this is how you would create a table in a database. So an example of a table is student, and column 1 could be net ID, and the data type would be string. Age could be integer, and you can have a lot of things about a student, and that would be a table itself. So the green, we usually write that all in uppercase so that we can differentiate that in our brains that, okay, that's SQL, and the stuff in the lowercase is the data types that I'm defining. So this is what it would look like if we actually had a user table and we had ID, name, age, email, and to give you guys some background, integer primary key auto increment. So integer, you guys know what that is. Primary key is like saying this is the field that I want to be using as the ID. So no one row in this table can have the same ID, which means that it's going to be unique. And auto increment means that anytime I add more things to my table, I want the ID to increment by 1. Text is just SQL language, whatever jargon for string. Not null means that if someone tries to create a user and they don't send me a name, then I'm going to throw an error. SQL is going to shout at you because I define that the text should not be null, and same goes for age. So you can't create a user if they don't have a name or an age. And email here, so char is basically just string, but in SQL we just say char, and the maximum character length is going to be 50. So these are just some very specific things that you can always search up, and yeah. Okay, so inserting data. Here I'm just trying to insert my stuff into the fields that I named. So for example, if I'm trying to insert into my Cornell students database and my column 1 was Cornell net ID, and column 2 was the age, if I wanted to insert data at a specific point, I would say, okay, I want to update my age to be 20 and I want to update my net ID to be blah, 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 blah. That's how you would do it. If you want to insert into all of the columns, so let's say I want to update all of the values of my data in the database, I don't actually have to list all the column names. It's only when I have specific columns that I want to update for. So this is just something neat. Yep, and this is a really nice example. Okay, so what about getting data? This is just select from the specific column that I want from the table name. So let's say I want all the Cornell net IDs from the Cornell student database so that I can register all of them onto CMS for the Intro to Backend course. Then I would just say select net ID from student. And the star is a keyword for selecting all of the columns. So let's say I wanted to get the net ID and the name and the age and where they came from, all of that, then I would just say select star. Also, before I talk about retrieving data, make sure that you have a semicolon at the end of all of your commands, because this actually makes a difference. It tells SQL that you are done with your SQL command. And getting data is, you can be more descriptive about the condition that you want. So let's say I only want Cornell net IDs from Cornell students who are taking the Intro to Backend course, and that would be my condition. And this is just getting all of the users who are older than or equal to 18 years. Updating the data is also very similar. It's you choose the table that you want to update in and the specific columns that you want to update wherever something is true or false. And this is just another example. Deleting the data is also very similar. You say which data table that you want to delete from on some specific condition that you want. And this is just deleting the user with ID 1. All right, that concludes lecture 2. Just a reminder that PA1 was due on Sunday, 11:59 p.m. EST. If you didn't make that deadline, don't worry. Our late deadlines are always the Wednesday after at 11:59 EST. This is just going to be a flat -2 penalty, so we won't be offering any extensions. It's just, if you want to take the L, it will only be -2. Don't worry about it, and you won't ever fail the course because of that. All right, so we will be releasing PA2 on Monday, if this is before Monday. So good luck with that, and don't be afraid to ask questions on Piazza. Good luck.